Welcome in now. It's time to do the four-step method with this new z-test that we have. So here's a big long description, okay, and lots of information given to you. Okay, pause the video, read it if you need to, but the main question that we're investigating here is this one that I'll highlight. Is there evidence that the mean LDL level is above 130 among diabetics? And so we're going to look at this using the four-step method, state, plan, solve, conclude. If you need to review the components, please do. I'm going to press on. Okay, I do have everything annotated, so pause the video as you need to copy things down or let it sink in. Okay, so in the state step, we're just stating what we need to investigate it, and the thing that we are investigating is if there's evidence that the mean LDL level is above 130 among diabetics. That's the highlighted question. Just frames as a statement. Okay. Now in the plan step, this is long, so pause the video as you need to. Okay. Yep, I can barely get it all on one screen. Okay. So in the plan step, this is where I need to kind of state my approach, and I need to state the variable. Okay, so the mean LDL level is a quantitative continuous variable. Okay, next I need to also, so whatever approach I identify, so one sample z-test, I need to state the requirements and check that they're satisfied. So I state the requirements, and then in red I kind of stated why they are met. So for IID, it mentions an SRS is taken. For the population being normally distributed, that's a given. That was stated explicitly in the prompt. Close to normal, that's enough for us. And then sigma is known and finite, and it gave us that the population mean was 30, or population standard deviation was 30. Okay, so now the next part is kind of new, because then this is where we start to kind of lay out what we're going to do. So first part is, so I'll just maybe highlight this here in green. This is all maybe newer for us, but specific for hypothesis test, this is where I would set up my hypothesis test, right? So I need to state the null and alternative. Okay, so mu is greater than, or mu is equal to 30, 130 for the null, and then the alternative is that above 130. So one-sided to the right test. Okay, I don't need to mention that. I need to define the symbol that I use. Okay, and then this last part here, kind of over here, this last sentence, two sentences rather, is kind of just articulating how I'm going to go about conducting the test. So I'm going to say I need to find x bar and n to find our test statistic. That's step one, and then with the test statistic, I can find the p-value and make a decision using that. And then it's helpful to state the level of significance as well. Okay, so overall plan step is massive, right? State the variable, state the assumptions, check the assumptions, and then articulate your approach in detail. Okay, then by comparison, the solve step and the conclude are relatively short. Okay, because in the solve step, we identify all the different pieces of information we need. So mu naught is 130, x bar is 125.6, that's the mean of our sample, 964, and then for the sample size, and then sigma is 30. Compute z, and then the p-value, I use the 1 minus norm.dis because I have a one-sided to the right test. And then I got a p-value of nearly 1, which is much bigger than 1%, so then I would fail to reject the null. So that's what I write in my conclude step. Okay, so since p is bigger than alpha, we fail to reject the null. Based on the data, there is insufficient evidence that, and then whatever the alternative is. So and then after I do that, then I just state the type of error that could have been made with the decision. So that's the type 2 error. Now, before I go on, I kind of want to talk about the general structure here. Okay, so the highlighted pieces are really the only pieces that are going to change from iteration to iteration as you write this out. Okay, so since p is less than alpha, the only other alternative is you have p is less than or equal to alpha. okay, which would mean that you would reject the null. Okay, so these would correspond, these two would correspond as with the highlighted pieces. Similarly, if you reject the null, that means you have sufficient evidence for the alternative. Sufficient, oh my gosh, I can't spell right now. Let's try this again. Sufficient. Okay, so that means you have evidence for the alternative. The alternative, I highlighted that just because that always has to go there, but the other pieces here that I've highlighted can change. Okay, so that's the general structure to the 4-step method. Again, I didn't take time to write it all out because I don't think you want to hear me annotate slowly and watch a literally about 15 or 20-minute video. So you might need to pause, gather the information as needed, and then formulate all this. But every 4-step method for a z-test should follow this general structure. So you'll have some experience with this in class as we move forward.